We're going to start our probability unit with single events. So basics of probability, when flipping a coin, what is the probability of flipping a heads? Well, on a coin, there are two different sides. It's either going to be heads or it will be tails. So when you flip a coin, the probability is heads, 1 out of 2, which is equal to 0.5. Number 2, when rolling a die, what is the probability of rolling a prime number? Well, when you roll a die, you can roll a 1, 2, 3, 4, 5, or 6. Of the 6 total numbers that you have, probability it would be a prime number, 2, 3, and 5. So 3 out of the 6 numbers could potentially be prime, which reduces to 1/2. You could also write it as a decimal, 0.5. So in the first two examples that we had, we were finding the likelihood of that particular event occurring. So that's actually how we define probability. It is simply the likelihood of an event occurring. What you see here is the probability of an event, and how you would find the probability of any event occurring is always, we first looked for the total number in our entire sample. So for number 1, for example, the sample of when you flip a coin, there were possible 2 outcomes. When rolling a die, the sample space, the total number of ways that this can happen, 6 different outcomes. So in the denominator, what we're always finding is the number of total ways in a sample space. And our numerator would be how many ways can that particular event that we're looking for occur. So when we flip a coin, the probability of flipping a head, there was only one possible way that that could occur. When we roll a prime number, there are 1, 2, 3 different ways that this could occur, which was always our numerator. So in our numerator, it would be the number of ways an event can occur. And instead of writing it all in words, I could also rewrite that as the number of ways the event can occur. And for the denominator, it would be the total number in my sample space. Something you will have to be familiar with in order to answer questions 3, 4, 5, and 6 is what a deck of cards looks like, how many of each type of card there are in each deck of cards. So at this time, you can pause the video with this deck of cards in front of you to answer questions 3 through 6. So what you should have gotten for number 3, there are 4 queens total in your deck of cards, so 4 out of 52 or 1 out of 13 is the probability. For number 4, of the 52 cards in a deck, 13 of them, or exactly 1/4, are diamonds. So that's the probability of drawing a diamond. For question 5, there is only one type of card in your entire deck that is specifically the queen of diamonds. So the probability was 1 out of 52. And lastly, in number 6, so of the 52 cards in a deck, 12 of them would be face cards, or 3 out of 13. Now moving on to multiple selections in a single event. We're moving on from just a single selection. Previously, we were selecting a single card from the deck. Now what we're doing is selecting multiple items. In number 7, you're told that there's a bag that contains 3 orange, 4 blue, and 2 yellow marbles, and to draw the sample space. So there are a total of 9 different marbles. Same with the number 8, letter A, when you're asked to draw the sample space, I simply just drew in all the different types of M&Ms that we have, and there were a total of 55 M&Ms in our sample space. So in letter B for number 7, what is the probability that if you choose a single marble from the bag, you will choose a blue marble? Well, we always want to find the probability of any event by finding the number of ways the event can occur out of the total number in my sample space. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles in my sample space. And of the 9 marbles that I have, what is the probability that I pick a blue marble? There are 4 blue marbles out of the total 9, so the probability is 4/9. Letter B, it's slightly different. It says, what is the probability that if you choose 2 blue marbles at a time? So we're no longer doing a single selection. We're not selecting one single marble. Now we are being asked, how about choosing 2 marbles at the same time? What is that probability? What I have on this slide here, we'll go back and forth, is how many different ways can we choose 2 blue marbles at a time? Well, I specified all the different types of marbles I have. I have 1 orange, I have a second orange marble, I have a third orange marble, I have 1 blue marble, another blue marble, etc. And I found all the different ways that I can have 2 different marbles selected at the same time. So for the first selection, I could pick 2 orange marbles, the first orange marble and the second orange marble, or I could pick the first orange marble and the third orange marble, etc. And I found out all the different possible combinations for all of the 9 marbles that I have. And what I end up getting here is that I have 36. So I have a total of 36 different possible combinations of 2 marbles. How many different ways can I select 2 blue marbles at a time? So I would just simply find all the combinations that have 2 blue marbles. That's 1, 2, 3, 4, 5, 6. I'm going to scan it over one more time to make sure. However, I did find that there are a total of 6 different ways that I can select 2 blue marbles. So 6 out of the 36 would equal 1/6. That is a probability that I choose 2 blue marbles at a time. However, it would obviously not be realistic for you to draw out the entire sample space every single time. So of course there must be some kind of shortcut to this. And to do this, we use something called a combination. So a combination would be the formula n factorial divided by r factorial times n minus r factorial. For a combination, you can see it written one of 2 ways. You could see it as either the combination of n comma r, or you could see it written as NCR. Either way, the C is representing that you have a combination. So you're trying to find how many different combinations of 2 or 3 or 4 things you can create. And N represents the total number you have. And R represents the number you're selecting. A factorial, which basically looks like an exclamation mark, would be the product of that integer and all the integers below it. So for example, 5 factorial would represent 5 times 4 times 3 times 2 times 1. So that would equal 120. Now going back to our previous example, we wanted to know how many different ways can we select 2 blue marbles at a time. We know that the probability of any event occurring is equal to the number of ways our event can occur out of the total number in our sample space. So we can do this one at a time. First of all, how many different ways can we select just any 2 marbles out of the total 9 marbles that we're given? We can use a combination to answer this question. I could either write it as the combination of 9, 2, or I could write it as 9C2. Again, they are both equivalent to one another, but what they represent is the formula n factorial divided by r factorial times n minus r factorial. So if I know that 9 is the total number of marbles that I have, that would be 9 factorial divided by the total number of marbles I want to select, 2 factorial, times 9 minus 2 factorial. This is the formula that we have to find our answer. We already know based off of the diagram that I had drawn for us here that we have a total of 36 on our entire sample space. And we're going to use this formula to end up getting the same answer. Again, I want 36 to be the answer to this combination. If 9 factorial represents 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, 2 factorial is equivalent to 2 times 1, times 9 minus 2 factorial is equivalent to 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. What I notice is that in my numerator and denominator, most of the products will just eventually equal 1. So 7 divided by 7, 6 over 6, 5, 5, 4, 3, 2, 1 divided by 1 is just 1. And then I'm ultimately left with 9 times 8, which is equal to 72, divided by 2, and I do end up getting 36. So if I have 9 different marbles and I want to select 2 of them, there are a total of 36 different ways that this can happen. And again, we're simply just using our formula. In the same way, I can find my numerator. So my numerator is, more specifically, how can I select 2 blue marbles, or how many different ways can I select 2 blue marbles? I would say that of the 4 blue marbles that I have, how many different ways can I select 2 of them? So this would be a combination of 4, 2. And at this point, instead of expanding it, which we can do, I am able to write it as 4 factorial divided by 2 factorial times 4 minus 2 factorial. You can actually also use your calculators. On every scientific and graphing calculator, there are buttons on all of your calculators. Again, what I'm trying to do is evaluate what the combination of 4, 2 is. Somewhere on your calculators, you should see a button that says probability. So PRB is the button that you would see, again, on a TI-30X. And once you click on that, you see the options NPR, you see NCR, and you see a factorial. You're going to use the arrow buttons on your calculator to navigate over and make sure that you have NCR underlined, and that's how you would use that function. In order to use this function for a scientific calculator, what you would want to do in this specific order is type in 4, then press the probability button, then navigate over to NCR, press enter, and what you should see on your calculator screens would be 4 NCR, and then you would type in the number 2. Once you have all that written in, you press enter one more time, and you should see the number 6 appear on your calculator screens. So how many different ways can you select 2 blue marbles of the 4 blue marbles? 6 different ways. Again, we had already found that answer, but now we are able to use the combination function in order to find how many different ways we can select that, as opposed to drawing out the entire sample space and counting. Now going back to answer our question, we found this 2 different ways, one using the combination, another drawing the sample space. With the probability you choose 2 marbles at a time that you choose 2 blue marbles, it would have been 6 out of 36, or 1/6. Moving on to letter D, what is the probability that if you choose 3 marbles at a time, you will choose 3 orange marbles? So this time we are selecting 3 marbles at a time. Instead of drawing an entire sample space of all the different ways that we can select 3 marbles, we know that we could simply do a combination. For the probability of any event occurring, it's always going to equal the number of ways the event can occur over the total number in my sample space. My sample space is how many different ways can I just select any 3 marbles. Any 3 marbles means that of the total 9 marbles that I have, how many different ways can I select 3 of them? That would be the combination of 9, 3 or 9C3. Again, I'm able to use the formula or the function for this, 9 factorial divided by 3 factorial times 6 minus 3 factorial. Otherwise, I could also just use my calculator to do this function for me. I would start with typing in the number 9, selecting the probability button on my calculator and navigating over to underline NCR. Click enter, type in the number 3, type enter one more time, and I found that this is equal to 84, meaning that there are 84 different ways that I can select any 3 marbles. So that would be the total number in my sample space. And now answering the numerator portion. That is specifically asking how many different ways can I select 3 orange marbles? Well, this would be of the total 3 marbles that I have that are orange, how many different ways can I select 3 of them? Logically, you should know that the answer to this is only going to be 1. If there are only 3 marbles, there's only one way that you're going to select all 3 of them. You could also use your calculator just to verify. However, we know that the combination of 3, 3 would be 3 factorial over 3 factorial times 3 minus 3 factorial, which is 0 factorial. Even though you end up having 0 factorial, at this point I do want to mention that 0 factorial is equal to 1. And this is by definition of 0 factorial. So 3 factorial divided by 3 factorial is essentially equal to 1. You could also type that into your calculator, 3, probability, NCR, 3, click enter, and you'll also see that that is equal to 1. Again, this logically should make sense to us. So there is one way that we can select all 3 marbles that are orange. So the probability of this occurring would be 1 out of 84, or as a decimal, it's approximately 0.012. And the last example, letter E. What is the probability that if you choose 4 marbles at a time, you will choose 4 blue marbles? Again, similarly to what we did in letters C and D, we want to know how many different ways can I select any 4 marbles of the 9 marbles that I have. So the probability of this event occurring, which is again the number of ways the event can occur over the number in my sample, would be equal to, of the 9 marbles that I have, how many different ways can I select 4 of them? In my calculator, I would type in 9, NCR 4, and I find that there are 126 different ways that I can select any 4 marbles at the same time. Moving on to the numerator, how many different ways can the event occur? Well, the event specifically is that I select 4 blue marbles. This is just like letter D, where there are only 4 blue marbles and I want to select all 4 of them. So the combination of 4, 4 is just equal to 1. There's only one possible way that that could happen. So the probability that this happens would be 1 out of the total 126, which would be approximately 0.008. At this time, if you can go ahead and pause the video and work on question number 8, you're going to answer letters B, C, and D. Please be prepared to share your answers for letters B, C, and D next class. And now we'll move on to question number 9. In number 9, it states, if you were randomly selecting letters from the word Pacific, what is the probability of selecting 1 consonant, 1 vowel, 3 vowels at a time, and 3 consonants at a time? You're ultimately asked 4 separate questions, so we'll start with the first one. What is the probability of selecting 1 consonant? Let's take a look at the word Pacific. Pacific is made up of P-A-C-I-F-I-C. There are a total of 7 distinct letters that create that word. Of these 7 letters that we have, if we're simply selecting 1 letter and we want it to be a consonant, The consonants would be P, C, F, C. One consonant. We're just doing a single selection, so of these 7 total letters in my sample space, the probability that we select one consonant would be 4 out of 7. Now moving on to one vowel. We're still doing a single selection, so there are 7 different letters that I can pick from my entire sample space. And of the 7 letters, the probability I select a vowel, I have 1, 2, 3 letters that are vowels, so the probability would be 3 out of 7. Now 3 vowels at a time. This question is slightly different because now we are not doing a single selection, we are doing a multiple selection. So I want there to be 3 vowels at a time. If the probability is the number of ways the event can happen over the number in my sample, I need to know, first of all, how many different ways can I select just 3 letters from the word Pacific at the same time. For example, I can pick PAC, I can pick PCI, I can pick PFI, etc. Instead of writing down all the different ways that this could happen, we know that we can use a combination to answer this question. Of the total 7 letters that I have, how many different ways can I just select any 3 of them? That would be the combination of 7, 3. I'm going to type that into my calculator very quickly. 7 NCR 3. And I find that there are 35 different ways that I can just select any 3 letters. Now moving on to the numerator, the number of ways the event can occur. The event specifically is me picking 3 vowels at the same time. If I look at the vowels that I have though, I just have A, I. Those are the only vowels, and in order for me to select 3 vowels, I would have to select all of them at once. How many different ways that can this happen? It can only happen in one way. Again, if you want to use a combination to verify that 1 is the correct answer, we know that we can use a combination. Of the total 3 vowels that I have, how many different ways can I select 3 of them? That would be the combination of 3, 3, which would also equal just 1. And lastly, 3 consonants. I'm also no longer doing a single selection here. I want to know how many different ways can I select 3 letters that are all consonants. So my numerator would actually be the same as when I chose 3 vowels. My sample space is how many different ways can I select 3 letters out of the total 7. Again, it would be just the combination of 7 and I'm selecting 3, which is still going to equal 35. My numerator, however, is of course going to be slightly different. My numerator would be the number of ways the event can occur, and my event this time is that I select 3 consonants. You could write them out to figure it out. You can choose PCF, you can choose CCF, etc. The other way that you can do it, instead of writing out the different ways that you can select 3 consonants, you could also find a combination of the 4 consonants that I have. How many different ways can I select 3 of them? The combination of 4, 3 would be 4. There are 4 ways that I can select 3 consonants. So the probability of this happening would be 4 out of 35. In question 10, it says there's a group of 10 students in a committee, 6 of whom are girls. What is the probability that the committee's leader will be a girl? We'll answer that part of the question first. The probability that the leader is a girl. This is a single selection. I am only picking one person and I want that one person to be a girl. The denominator, how many total is in my sample space? There are 10 students total in my committee. Of the 10 students, how many are girls? 6 are girls, so the probability of this occurring is 60%, or 3 out of 5. Now the second part of this question, what is the probability that their 3-person cabinet will be all girls? Now we're making a selection, not a single selection, but we're making a multiple selection. I want to know how many different ways can I select 3 different students. So of the 10 students that I have, I want to know what is the sample space if I were to select 3 separate students. Or I can say, what is the combination of 10, 3? So 10 NCR 3, there are 120 different ways that I can select 3 different students of the 10 students in my committee. Question, it says, the 3-person cabinet will be all girls. So I know that there's 120 ways in general that I could pick 3 students of the 10. How many different ways, though, can I create a group of all 3 girls? This is another combination. I want to know, of these 6 girls that I have, how many different ways can I select 3 of them? So the combination of 6, 3. The combination of 6, 3 is equal to 20. So there are 20 different ways that I can select 3 girls of the 6 that I have. So the probability that the cabinet is all girls would be 1 out of 6. I would like you to pause the video and answer questions 11 and 12 at this time. And please be prepared to share your answers to 11 and 12 during our conference next class. All of the previous problems dealt with selecting multiple items from a single event. Now, we're going to talk about arrangements of multiple items in a single event. What's the difference? What is the difference between a selection versus an arrangement? Let's take a look at this example. I currently have 6 unique marbles in front of us, and let's say I asked, how many different ways can you select 3 marbles? So a selection, we said, was a combination. How many different ways can I select 3 different marbles? That would just be a combination of 6, 3, which is 6 factorial divided by 3 factorial times 6 minus 3 factorial. And we know that we would have 20 different ways that we could select 3 marbles. The order doesn't really matter. I just want to know how many different ways can I select any 3 of them. That's what a selection really is. And let's say instead that I changed the wording of my question. I'm no longer asking how many different ways can I select 3 marbles. I care about the order in which they are selected. So then, if I take a look at the one selection that I started with, this is the very first selection that I made right here. If I said that the order did matter, then instead of just having a red, blue, and a green, then I can also have a blue, red, green, or a blue, green, red, or a red, green, blue, etc. I have a ton more options when I am doing an actual arrangement. And of course, this is because the order matters. When would this apply? Let's say that I am taking people to Disneyland. Of the 30 students in the class, I want to select 5 of them. What is the probability of that occurring? Well, you wouldn't really care if you were the first person chosen to go to Disneyland or you were the last person, because you're one of the 5 people that I chose. If you're first or last, you're still going to go to Disneyland no matter what, so that would simply be a selection where the order doesn't matter. However, the scenario does change if I change the situation. So let's say that I have 30 students in my class, and I want to know how many different ways can I arrange 5 students in the row closest to my desk. Well, at this point, of course, there would be many more answers. I'm not just selecting any random 5 students to be in one of the seats, because the order that you guys are seated in does matter. Even though I'm still picking 5 students, the arrangement is going to be different every time. It will make a difference whether you're seated in the first desk or you're seated in the last desk at the back of the room. Because of that, we would need to do a permutation in order to find the answer to that question. We already said we know what a combination is. A combination of 6, 3 is equal to 6 factorial divided by 3 factorial times 6 minus 3 factorial. Now, if the order matters, such as this particular example here where I take one of these selections that I had and I rearrange them in different orders, then we need to use a permutation. And the formula permutation of n, r So it's the same variables that we used for a combination, but this formula is n factorial divided by n minus r factorial. We have the permutation of 6, 3 to know how many different ways can I arrange these marbles here. It would be 6 factorial divided by 6 minus 3 factorial. And now we can use the NPR function that is on our calculators. Originally, we were navigating over to NCR, but if you can on your calculator screens, type in the number 6, press the probability button, and make sure that you have underlined NPR. Click enter, type in the number 3, and here we end up getting 120. Again, originally the combination was equal to just 20. Those were the 20 examples that we originally had, but we know that there's going to be 6 times more for a permutation if the order matters, because for this one example here, we saw that there were 5 more. So for every type of selection, there were a total of 6 for an arrangement. And if you actually take a closer look at the formulas, you'll understand why. Of course, for a permutation, the number will always be larger. So the combination of n comma r was n factorial over r factorial times n minus r factorial. What we have here is this r factorial, and this r factorial is basically removing any of the repetition. By dividing it by r factorial, we were basically getting rid of all the ones that would be repeating. For a permutation, of course, we want to keep all the different arrangements, so we do not divide it by r factorial as well. One more time, this r factorial removes any repetition. Now in number 13, the number of ways of arranging items is different from the number of ways of selecting them. Consider the name Mark. What is the probability of selecting the letters M, A, R, and K from the alphabet? We'll answer that part of the question first before moving on to the next one. This here is simply just a selection. The order in which I choose these letters do not matter. I can select R, M, A, K, R, A, M, K, etc. It's just a simple selection. I am doing a multiple selection though, because I am choosing 4 letters at the same time. So this would be a combination of 26, 4. Of the total 26 letters that I have in the alphabet, how many different ways can I select 4 of them? In your calculators, you would type in 26, probability, NCR 4, and there are a total of 14,950 different ways that I can select 4 letters from the 26 letters in our alphabet. How many different ways can I select M-A-R-K? Well, there would only be one way that I can select all 4 of the letters. It's if I choose all of them or not. Again, this would be a combination as well of 4, 4. Of the 4 different letters, how many different ways can I select all 4 of them? There was just one possible way. So to answer the first part of this question, it's simply just 1 out of 14,950. The second part of this question, what is the probability of arranging 4 letters at random and spelling Mark? The way that the name is spelled matters. It would not be correct to get M-R-A-K. That would not be correct. I would need it to spell Mark exactly. Then this means that it's an example of a permutation because, again, the order matters. So how many different ways can I arrange just 4 letters from my alphabet in general? It would be the permutation of 26, 4. In my calculator, I'm going to do this one more time. And I find, of course, like I expected, that there are obviously many more ways to arrange 4 letters than just to select any 4 letters. This would be 358,800 different ways that I can arrange 4 different letters in the alphabet. What is the probability of the event occurring? Well, the event is that I spell the word Mark. And of course, there is only one possible way that I would spell the word Mark from my alphabet, so the probability would be 1 out of the 358,800. In question 14, if you choose all 4 letters, what is the probability that you would select the letters in correct alphabetical order? The chances of this obviously would be so extremely low, but the probability of this event occurring would be the number of ways the event can occur over the number in my sample space. The number that my event can occur, if my event is that I spell all the letters in correct alphabetical order, that would just be one way that happens, that it's A, B, C, D, E, F, G, etc., all the way until Z. My denominator, how many different ways can I arrange 26 letters? That would be the permutation of the 26 letters that I am selecting. That would be the permutation of the 26 letters that I have, and how many different ways can I arrange all 26 of them. So the permutation of 26 and arranging all 26 of them is an extremely large number. It is 1 out of 4.03 times 10 to the 26th power. Again, if I'm trying to arrange all 26 letters of the 26 letters that I have so many ways that can happen. The probability that this happens, though, 1 out of 4.03 times 10 to the 26th power is essentially 0. In number 15, when buying a combination lock, what is the likelihood of buying one that will open with 1, 2, 3, assuming no number can be used more than once? On a standard combination lock, generally it goes from 0 all the way until 39. So that means that there are a total of 40 different numbers that exist on a combination lock. Again, there are some combination locks that have very specific rules to it, such as you can't have all even numbers or odd numbers, etc. But we're just going to assume that for this particular problem, you just cannot use the same number more than one time. So you cannot have a combination lock like 1, 2, 1 or 1, 1, 1, etc. So to answer this question, we need to know how many different ways can the event occur out of the total number of ways that my sample space can occur. Because I have 40 different numbers, and of course for a combination lock, the order in which I get these numbers do matter. For example, having a combination lock of 1, 2, 3 is obviously different than 3, 1, 2, even though the same numbers are being used. This would be an example of a permutation. It would be the permutation of the 40 numbers that I have. How many different ways can I arrange 3 of them? That's the denominator, or the number in my sample space. My numerator would be the number of ways the specific event can occur. How many different ways can I get 1, 2, 3 in that exact order? There is only one possible way that could happen if I get 1, 2, 3 in that order. The probability that this occurs would be 1 out of a total 59,280. For question number 16, highly recommend that you start off with a diagram, 1, 2, 3, 4, 5, 6, 7 empty seats, and you really want to sit next to your friend of choice. And again, there are 5 of you total. There's you plus the 4 friends that you go with. Go ahead and attempt this problem, and we will be going over it together in conference.